Welcome everyone to the November 13th, 2017 Kubernetes SIG Apps. The agenda, let me go ahead and paste that into chat here. And so there I've shared the agenda. And we've got a handful of things. So before we get into today, we've got some updates from core projects and from ecosystem projects. We've got a discussion, and we have a demo maybe, and a number of announcements. So I'm going to start with the announcements. First of all, normally around the US Thanksgiving holiday, because so many people are out, we have a tendency to cancel the Monday before Thanksgiving. There's been some talk about the Monday before Thanksgiving, because I know some people take off those 3 days to get a really long chunk of time off, or the Monday following. Do we have any preference on this or thoughts from folks? The current plan is to take off next Monday because just so many people would be gone. Can you all hear me? All right, does anybody have any opinion? Okay, give me thumbs up for you with video. Does next Monday off sound good as far as for the Thanksgiving holiday? All right, that's what we normally do. Okay, so we won't have one then, and then the next meeting will be on the 27th. The next announcement that I wanted to say here was that we've started to record or try to record the Helm and Charts meetings that happen separately. Right now they're happening on Thursdays or every other Thursday, depending on the meeting. And we will have a YouTube video channel for that. I think we've got it, and we're going to start getting the videos up and attached to it. And so look out for that if you're interested in what's happening in those conversations as well. That all falls under SIG Apps, but we've actually gotten a separate channel for those because it's kind of a subtopic of everything that we do. And so look out for that coming. Hopefully by the 27th, I'll be able to share a URL or on the list before then. The other thing that isn't on here for the announcements, we'll be updating the calendar invite for this meeting to a new invite soon because of some logistical stuff. We don't control the invite anymore, which is why some folks have asked for, can you get the agenda attached to it? Can we get some changes to it? It turns out we don't actually control that invite anymore, and we've got to go clean that up. And so we'll be getting a new invite here in the near future. So keep a lookout for that. Probably on the 27th, I'll announce it, and it'll come out to the list by then. We're just giving you a heads up. And so with that, those are our quick announcements. We can go into updates on Kubernetes core. Do we have anybody on who can talk about what's going on with the sets or the stateful set, those things, the workload API? Do we have anyone who can talk about how it's going? I know this time we're talking about moving it from apps v1 beta 2 to apps v1. So we've got somebody who's not on mute who's typing pretty loudly. Could you go on mute if you're not talking? Thank you. So it doesn't sound like we have anybody on to talk about that. All right, so we're going to actually have to get on that pretty soon for anybody who knows or is interested in this topic, because we have Code Slush coming up on Monday the 20th and Code Freeze on the 22nd. And so if we're actually going to make that switch and pull it off cleanly across everything, we need to get it done now. And so I'll fire off some emails. Ken, I see you're on now. We were actually just talking about the workloads API and looking to discuss just an update on it, because we know we're coming into Code Slush and Code Freeze and getting it moved over from apps v1 beta 2 to apps v1. Do we have any status or knowledge on that? Oh, maybe not. All right, we'll have to chase this one down offline. If anybody runs into somebody working on that, please chase them down and make sure. Otherwise, I'll be doing that as well. Then we've got jobs. We do have a flaky failing test for jobs as well. Is anybody on to talk about jobs? Who can talk about them? That's jobs and cron job. All right, I'll have to chase that one down as well. All right, so with that, we have a demo lined up on Brigade. Matt, are you there? Are you able to do a Brigade demo?
I think so.
All right, well, the floor is yours.
Okay. There's a great blog post on the Microsoft blog about Brigade if you want to get started and kind of read up on it. But and Newstack ran an article recently about it too. But in a nutshell, what we wanted to do was we wanted to build a system that would work sort of like shell scripting for Kubernetes. So when you think of writing like a bash shell script, this is kind of how it goes, right? You say, okay, there are a bunch of tools that I already have on my system that accomplish bits and pieces of various tasks, right? There's a sort command I can use to sort stuff. There's an ls command I can use to list the directories of in my file system, and so on, right? There are a bunch of binary commands that each do separate things. But a shell script is basically a way of combining them and building something bigger and better out of those things. So, I add a little bit of control structures, I add a little bit of looping and things like that, and suddenly my 8 or 10 different disparate binary commands that exist on my operating system can be glued together to build something more elaborate. Now, when we looked at the way Kubernetes was going, we noticed some interesting trends, and one of them is that Kubernetes is remarkably good at running one-off tasks. We have both the job API and sort of the pod primitive. The batch API has jobs in it and the pod primitive, both of which are very good at running individual tasks. But it's also very good at running servers, right? And we have focused very heavily on operating servers on Kubernetes, but not so much on running individual tasks. So we got to playing around with this, and we said, what could we do that would show off more of Kubernetes usefulness when it comes to running these tasks? And we thought, well, on a standard operating system, the kinds of things you like to be able to do is script up different things and be able to run them. And that's what sort of set us on the course about 1.5 years ago to writing Brigade. Brigade is essentially a tool for building pipelines in Kubernetes, scripting pipelines in Kubernetes, so that you can kick off a particular task or a particular, at a very high level, right? I want to kick off some process and have it run a whole bunch of individual jobs and pass data from one part to another, much like a shell script works. So what you're going to see here is a demo of that particular tool. Very, very early, we released it a couple weeks ago at the Open Source Summit in the EU, but it's already at that point where you can do some kind of interesting things with it. And the way it works is we set up an event-driven system so that you can trigger events, and an event will cause a script to execute. And the script will call out to other entities. Now, instead of calling out to binaries like you would do in a shell script or executables on the local file system, we decided that the right primitive to shoot for in a cloud-native world would be a container. So what you're going to see is a way of event-driven scripting of execution of, well, essentially 0 or more containers in such a way that you can chain them together and do some fairly elaborate things with them. All right, so I'm going to try and share my screen here. I'm just going to share the console. I know Michelle is on, so I'll bump the size up a little bit. Okay. In chat, if anybody's having trouble seeing that, let me know there. As Farina says, silence means no, so let's try clearing that again. All right, so here I am in a directory. I've got a Brigade script here. Now, Brigade can listen to all kinds of events. So you can set it up to listen to GitHub webhooks. You can write fairly sophisticated ones on your own. But the most trivial one that we can do is to just use the Brigade command line, which is Brig. So this is Brig here. Brig has a couple of interesting commands. So we're going to just list out projects. So when I create a new Brig setup, I create projects. And a project is basically the way for me to divvy up who's allowed to do what where, okay? And a script then gets assigned to a project. So I've got a couple projects there. One of them is my little Twitter testing one that uses Twitter as a gateway and sends Twitter messages back, but I'm not going to show that one today. Instead, I'm going to use this empty test bed one. So I'm going to run a script. Let's take a look at this script. Here's my script. Okay, so it's a very simple JavaScript. We picked JavaScript for a very, very, very straightforward reason. We went and looked at all the language rankings on all the different languages, compiled and uncompiled, and JavaScript tends to float in the top 3 positions on just about every language ranking we could find. So we went, all right, if we're going to try and do something that's easy to use, let's go with the one that hovers right at the top. So we picked a JavaScript engine, and so the language for expressing these scripts is JavaScript. So here's my little Brigade script. All it's going to do is it's going to listen on an event called exec, which happens to be Brigade's default event. And every time the exec event is fired, it's going to log the console message we. Okay, so now we can run this script. So with Brig, I just run by telling it what the script is and what project it's going to run in, and basically it's going to upload this script into the project and then execute it. So here we go. So behind the scenes now, it's starting up a couple of pods inside of my Kubernetes cluster. It's starting up a kind of master worker pod, which is the important one. And that one's going and firing off, and there we go. So it started up a master worker pod, loaded the JavaScript into it, dropped to the console the message we, and then destroyed it, okay? So let's kind of start to get a little idea for what else we can do with this, okay? So the way you chain things together is you declare jobs. So here's what a job looks like. We'll be proper and do var j1 equals new job. So every job has to have a name, and then a job will execute a pod or a container. So I'm going to specify one for us. What is the current Alpine? Is it 3.5, 3.6? We'll go with 3.6. Okay. So this is just going to download and execute, or this is actually just going to load up the Alpine container. If we want to run the Alpine container, we just tell it, hey, we want you to run that. Okay. So right now we have a script that if I ran it would just start up a new pod running Alpine 3.6, run whatever its default target was, and then exit. Not terribly interesting because Alpine has no default tasks. So what we're going to do is we're going to have it do something for us. So now inside of a job, you can create tasks. You can think of, so this is sort of like the ETL sort of lingo where you encapsulate work into smaller and smaller units, and the task is sort of the finest grained unit of work, and a job is the next one up. But practically speaking, what this is doing is anything that's in the tasks list is getting executed inside the container. So the job says, this is the container I want to use, and the task says, this is what you're going to do inside the container. So if I were, for example, compiling a Go program, I could pull down the Golang colon, 1.8 pod or whatever, and then in my tasks list, I could do a Go build or something like that. But I'm just going to do something in simple JavaScript or a simple shell command here and do an echo hello. So let's go run this one here. So now it should spin up our master worker pod, which is the Node.js pod that's running this script. And errors are always a good example to show what I did wrong. I did not import my jobs item here at the top. There we go. So now it's going to spin up first the worker pod, execute the JS in there. That worker pod is going to start its own hello world one. And we can see that the hello world one actually started up here and then fired and then exited. Now I didn't see the hello because I didn't tell it to do anything with that. I would have to dump that information back out to the console if I wanted to do that. So we use, if you're familiar with JavaScript's method of promises and promise resolution, that's basically what we do here. So here's our result, and we're going to resolve when that pod is finished. We're going to log that result out to our console. So again, we're running this. It's going to start up the worker pod. It's going to kick off that Alpine pod, but this time it's going to wait till that Alpine pod finishes, and then it's going to grab the result of that Alpine pod and dump it out to the command line. So here I can see, here's my hello. So pod echoed hello to its output. The JavaScript captured that and then logged that to my console. So the second important thing we should be able to do here is start chaining things together. So we should be able to execute things in order, right? Let's do a world here. So now I'm going to try and set it up so that I start not one pod, but 2 pods. And I'm going to use the shorthand notation here, echo world. Actually, I'm just going to echo hello 2 here because I don't want to make this too complicated. And I'm going to show you how to start grouping things together. So I've got 2 jobs now. First one will echo hello. Second one will echo also hello. Let's do that hello 2. And now I'm going to create a group. And a group is a way of saying, okay, I'm going to execute these things in order. I could just call j1.run, j2.run. By default, they'd execute in parallel. So they'd both be running in parallel. In fact, let's just do that. So this should run 2 pods for us and run them, sorry about that. Should run those in parallel. So we should see it try and start up both the J1 pod and the J2 pod, both around the same time. It actually started them both very fast, finished both of them. We see the output of the first one because we logged that one to the console. But we can get fairly sophisticated and we can start doing things like group. Well, so I can do group.run each, and I can say run J1 followed by J2. And what we see when we do this is it should run the first pod followed by the second pod. So you saw in that earlier example, it started up the 2 pods sort of in parallel. In this case, it's going to run the first one. Then once that one's done, it's going to run the second one. So there we go. So this is sort of like a short and simple demo of the kind of starting point for what we're working on with Brigade. So you can begin to imagine the kinds of things that you can do with a system like this, where you can take a fairly sophisticated set of containers, and you can pull those 2 containers I pulled there are just the straight up Alpine pods straight out of Docker Hub. Okay, so you don't have to write custom containers to use this. It's just like the way you shell script. When you shell script, you just use the commands the OS provides you, you add the right flags, you add the right arguments, and it just runs. And then you can pipe data from one to the other. That's basically the same kind of model that we're going after here. That you can execute container after container, you can pipe data from one into the other. There's some more sophisticated kinds of things that we could look at some point in the future, like being able to persist data from one job to another on a file system. So you can dump one thing, dump a bunch of files from one container and then read them back into the next container. And we also didn't look at gateways today. Gateways are the ways of piping data from outside the cluster in. If you go take a look at the Brigade repository, there's a video there where we basically take Trello and you drag items from one board to or from one column to another in Trello, and that acts as the trigger. It fires off an event, and that kicks off a Brigade script. So in that case, and then that in turn comes and notifies you via Slack that a thing was moved from one column to another, and it stores it in a database, because we can start to orchestrate some fairly elaborate pipelines by using Brigade this way. So what I wanted to give you today was just sort of like a very quick, relatively dirty demo of sort of like the core functionality of Brigade. And coming over time here, we'll start to show off some of the other features, probably not always in SIG apps, but here and there, and record some videos for you. But this was just designed to kind of give you a little bit of an introduction. Happy to answer any questions. Otherwise, that's all I got.
Thanks, Matt. Does anybody have any questions for him?
Hey, this is Josh. That was really cool. What was going on with the volumes for the volume claims in the output?
Good catch. Good catch. So behind the scenes, we want to make sure that job 1 and job 2 have some place where they can store information in a common space. So what you saw there is each time I spin up a new worker, it also grabs a PVC, and it grabs one that's a read-write many PVC. And it mounts that PVC to any job that asks to have a mount point for that. So say that I'm building, your kind of basic build tool chain, right? and I want to run a Go build on my first step. Say I've got a project that has some Go code and some JavaScript code, right? I want to run a Go build on my first step, so I want the Go container there. And I want to transcode some TypeScript to JavaScript in my second one. But I want to do that on the same piece of the same chunk of the file system. That PVC can get mounted to both pods, the Node pod and the Go pod, and then they have a shared space. And then at the end, you might spin up yet a third pod that tars everything up and posts it to Google Cloud Storage or Blob Storage in Azure or something like that. So we use that PVC system, and we're still kind of trying to tune that one up a little bit, which is why I didn't show it here, because right now it's kind of slow. But we want that PVC volume as sort of a way where we can mount the same shared file system to all of them. There's a second PVC volume that you can optionally mount that allows you to have a job cache. So again, going back to that Go example, say I want to cache data between two separate hook runs, okay? So, I want to cache my intermediary build data, or maybe the resolved version of my dependencies. I can do a cache which will span multiple builds for the same job. And then what you pointed out was a build-wide shared file storage that goes from one job to another. So we have both you can think of them as a horizontal and a vertical method of storing and sharing files. Rod asked, any thoughts on declarative API for Brigade, something like Concourse? We started with YAML, and we realized that just as it would be very difficult to have a completely declarative scripting language, it's very difficult to accomplish the main kind of stuff we do. But we had talked here and there about adding sort of like a simple YAML format on top to allow very basic pipelines. We just never bothered pursuing it. Because everything's written in JavaScript, you could actually implement that in JavaScript on your own, and that would be a relatively straightforward kind of thing. But our design goal was to build a scripting language, thus not necessarily declarative in the typical sense of like your straightforward YAML file or something like that. Does that answer that question? Cool.
I have a question about sort of, I guess, your intended scope. When you talked about processing events from Trello, it started reminding me a little bit of Lambda and some of the sort of workflow stuff that Amazon does. Is that something, is that an area that you have in mind? Do you have sort of like an upward limit on the volumes of events you could process in this way? Or do you have thoughts on developing into that area?
Yeah, very good questions. So first of all, comparisons to Lambda or any kind of function as a service are an interesting comparison, because in several ways you'll see notable overlap, especially the sort of the concept of an event-driven thing, which is by no means unique to a FAS sort of system, but it's definitely a prominent characteristic of a function as a service system. And the way I would describe this is, yeah, it is also an event-driven system, also can be used to solve many of the same class of problems. But with an inverted model, right? Where the Lambda model is you write the functions as the big piece, right? And so if a 5-step application requires 5 different Lambda functions to execute. We actually ended up sort of, and this wasn't intentional. We weren't intentionally trying to one-up Lambda or anything like that. We were just trying to realize our vision of a shell script. And what ended up being the case was ours focuses more on flow, where the implementation details are localized to containers, while Lambda and other kinds of things, the emphasis is on how you describe each step, and flow is sort of a secondary concern. So they end up being kind of interesting comparison contrast models. And sort of one of those things that we didn't really realize it till we were well down the path. And then we went, oh, wait a minute. People are going to ask us, how does this compare to, functions as a service? And at that point we went, oh, interesting. There's some definite overlaps and some definite differences. And in some cases you could use either tool to solve the same problem. And in some, one or the other is going to be a much clearer case. The second question you asked was volume-based, right? What's the volume something like this could handle? So our project's been open source for about 2 weeks. So, so we actually have no data about what the upper volume is. Our sort of intention when we designed it was, and this is mainly for organizational purposes, that you would tend to install Brigade into basically like your namespace inside of a cluster, or keep them relatively constrained, and you might have several different Brigade instances in several parts of your cluster. So we had never really designed it for high volume. That said, I imagine you would hit boundaries with Kubernetes, how many objects can be created in a namespace in some amount of time, and those would be gating factors for this. For sure, as this project goes on, it's in its infancy, and which means any of you are more than welcome to jump in and contribute with ideas and stuff like that. But because it's in its infancy, we haven't really had too much time to test out what the realistic limits of number of chains we could run at a time are, or anything like that. If anybody ends up testing it and hits some limits, please let us know, because it'd be nice to have some targets to shoot for. Thank you, Adam. Adam dropped into chat the link to the project, which is good. Brigade.sh is sort of like the front website to it, but it's the better place to go is straight to the GitHub repo and dive into the docs folder there. Any other questions?
Thank you, Matt, for the demo, and thanks everyone for the lively discussion. So with that, we have a handful of tooling stand-ups we wanted to walk through. If you have your own that you wanted to talk about, please feel free to add it to the list under tooling stand-ups, and we'll get to it. But we do have a number here, so let's start rocking through them and see who's here to talk about it. First one, there's a project called Telepresence. Is anybody here to talk about it?
Hi.
Hi. Can you not just talk about it, but fill us in on what that is? I think there's a number of folks who might not know what Telepresence is.
Sure. So Telepresence is basically a two-way proxy. It's designed for debugging and developing services in Kubernetes. So a lot of times when you're working on top of Kubernetes, it's really easy to create services that depend on a lot of other services. And that makes writing code kind of a pain, because you can't run that code locally, at least not easily. As soon as it grows too many other either Kubernetes service dependencies or external cloud dependencies. And so Telepresence aims to solve that problem. It really takes, the way it works is it takes a remote deployment in your cluster. It sticks a two-way proxy in that endpoint. That proxy can capture any incoming traffic that comes to that deployment, sends it down to your laptop. We then direct it to either a local process on your laptop, or a local container, or a local container network on your laptop. And then we also capture any outgoing network traffic, and we capture DNS as well from your application. So any outgoing traffic from either that process or the container network gets routed back into the cluster, just as if your code was actually running inside the cluster. We also proxy the environment variables down, and we proxy the file system down as well, so you can have access to any secrets or volume mounts or config maps that your code would need to access if it were actually running in the cluster. And this lets you use all of your local dev tooling sort of exactly the way you would if you're hacking on things locally, but actually run your code as if it was in the cluster. So that's basically what Telepresence does. Is there any questions about that?
Yeah, hi, this is Scott. I seem to remember when we were working on, after CoreOS Fest, there was a small working group to think about local development using Kubernetes. And not too long after that, Telepresence came up a lot in conversation. Mm-hmm. I was wondering if you wouldn't mind just going through that scenario. How would one do that? Or maybe I'm totally mistaken, and this is really not the tool for that. But at that point, we were talking about using host path and running locally using Minikube at that time. And I think like relatively soon, Docker for Mac is going to have native, or I guess maybe it does, and I just don't have the beta yet, but native Kubernetes stuff built in. But I think a lot of people are thinking, how are we going to develop locally with this if we're not going to use a cloud IDE?
Yeah.
Yeah.
Sure. So there's a couple of different strategies. And so one way is you can just forget about containers at all, just sort of run whatever application you're running locally, and then Telepresence provides two methods. It can use what's it called? It uses LD preload to override override network calls and intercept DNS, and you just, it's just sort of works as a process launcher that way. So instead of launching your application, you launch Telepresence and you pass it the name of your application. It launches that with the right LD preload set up to intercept outgoing network calls. And the other approach we have is the VPN method, which basically VPNs your host into the cluster, and it captures outgoing traffic that way. That's a little less sensitive. LD preload doesn't work with statically linked binaries. It doesn't work with Node. So there's certain applications that you can't develop using the LD preload method. The VPN method is more robust from an application perspective. It's also a little more brittle from an environmental perspective, because it messes with IP tables and stuff like that, and that just is that's different on every laptop. We've even found that Macs, which are all supposed to be the same, Macs of the exact same version running the exact same OS, which are all supposed to be the same, have random environmental differences that cause things to mysteriously break when you try and do that kind of stuff. So that's always a challenge, but when it works great. And then the other method is just tie into Docker networking. We basically run the VPN inside a network inside a Docker container, and then you can launch as many other containers as you want to, Docker containers locally as you want to, that are on that same network. And so if you have tooling that lets you if you're willing to put your development environment inside Docker, yet still keep it local, that's a pretty good option. And I know there's some tooling that there's some tooling that works pretty well with that, so you can still sort of have a nice experience with your local tools, get the fast feedback you want, but still be on sort of the cluster network that way. So that's kind of the mix of strategies available to you. I mean, one of the things we're interested in is getting feedback on what works for people, and sort of trying to streamline those dev experiences. We know people use it for debugging, and there's sort of certain cases where you can debug things a lot faster this way. We want to make it sort of more streamlined and better used for just sort of everyday dev experience, work out of the box. And so we want to find out, I'd say basically at a project level, we have two challenges and two things we're focusing on now, right? One is, as I said, testing, right? Because there's a lot of different permutations. There's a lot of there's different cluster versions. We try to work with OpenShift. We try to work with different versions of Kubernetes. We try to work with Minikube, and they're all a little bit different. And of course we try to work on Mac and Linux, and we even have some attempts at doing stuff on Windows as well. So there's a lot of permutations involved with testing all those different permutations. Is sort of complicated and slow. So we're looking at trying to figure out better strategies, better approaches for that. And then the other thing is just sort of getting feedback on, what are the different things that, what are the most useful ways people are using it? Because we're kind of flying a little bit blind. Like, we know certain things are more brittle than others, but we don't know what are the features that people use the most, and so we don't know where to sort of focus the efforts for the most sort of benefit. So I would say that's pretty much the state of things. This is my first stand-up, so I'm not sure if there's
That's all right. That's all right. Because it's your first, you went a little longer than we normally go, but you were able to fill people in on what's going on. So thank you.
Okay.
Yeah, and thanks for responding to my question. Appreciate that.
No worries.
All right. Then I guess we can move on to the Helm one. Do we have somebody who wants to talk about Helm and what's going on with it? Hello. I know we got a few of the Helm team here. Anybody still here paying attention?
What does the agenda item say?
The agenda item is stand-ups on Helm. What's going on?
Oh, just stand up?
Yeah.
Oh, I think, let's see, we have 271, I think we announced was released already, right? In SIG Apps last week.
I think it was going to be announced that it was going to be released. Is it out now?
Yes, it's out now.
Okay.
I believe it's out now. Yeah, we released it a couple weeks ago. So we're continuing down the 2.7 line of builds on that one. And the 2.8 stuff is getting queued up, but we're trying to sync up the 2.8 release, a week or two after the next major Kubernetes release, sooner if the Kubernetes APIs freeze sooner. We are well into the planning phase for the Helm Summit, and if Michelle is around and wants to jump in here, I'll let her do that, but we're targeting very early next year in Portland. I'll pause and see if Michelle's here.
Hey, yeah. I'm here. We're working on locking down a date for the venue. Right now it's scheduled for the first week of February, but that's not 110% confirmed. It's like 99% of the way there. And we originally had it for January, but plenty of people came back to me and said that was really close to KubeCon. They wanted me to move it to February, so that's what we did. The CFP is open. If somebody could drop a link to that form, that'd be really great. If you have a Helm story or something you'd like to talk about around the Helm community, like a plugin or a workflow tool that you created on top of it, you're welcome to submit a CFP. We're extending the CFP deadline to, I think, the first week after KubeCon, and you should get the results a week after that. That's it for me. I'll pass it back over to Matt Farina.
Thank you. And so the next one up is charts. And so I'll talk to charts real quick here. So we're talking about the community charts repo. And so there's a few things going on there. One of them is that we're talking about moving towards owners files, so that way different charts can have owners and not just a maintainer in the file, but they're able to merge and do other things on them to try to enable more people to merge things, to speed up the pace so the chart maintainers don't become a bottleneck on the process. That's going to take a little while, I'm guessing a couple of months, but we're looking at all the things needed to generate those files, make sure the right people have permissions on the repo, and then the bot. The current functionality that allows Kubernetes to do that is in something called Munch GitHub. It's being moved into Prow. So we're setting everything up, and then we're going to wait for Prow to take on that functionality, and then Prow is what we'll go ahead and move forward with. So we are looking at moving that over. And so that's one of the upcoming things to that repo. We're also looking at how we're going to end up with migration paths. So lots of folks are using things like apps v1 beta 2 on the workload API items that they're using. While in Kubernetes, I want to say 1.10, that's not going to be there anymore. So we're going to look at how we can start notifying people and get things moving to shift some of those things to use apps v1 or to get into capabilities and how that's going to work. We're also looking at enhancing some testing to help us be able to detect some of those things as well. But that's kind of what's happening over on charts. And so with that, I'll see, is anybody on to talk about Monocular? I don't see Adnan, so maybe not.
Is Monocular getting renamed officially at this point?
I don't know. So next time when Adnan's here, he can talk to it, hopefully. And then the next up is ChartMuseum. Do we have someone on to talk about ChartMuseum?
Hey, yep. This is Josh. So ChartMuseum, for those of you who don't know, is a very Helm-specific tool. It's a server to host your chart repository, and you can set it up to talk to your S3 bucket or Google Cloud bucket. We've had a lot of updates from these guys at Ubisoft for stability, as well as they've added Prometheus metrics, so which are enabled by default. What else? We need a lot of help in terms of the Helm chart for ChartMuseum. So right now you can go to the Kubernetes Helm incubator and run ChartMuseum, but it's using a, what is it called? A empty dir volume. So if anyone can get this working with S3 especially, a lot of people are looking for that. Also, we were talking a while ago about Azure support too. So if anyone's interested, please reach out to me. I'm on Slack. Thanks. There's also a ChartMuseum, what's it called, Slack channel as well.
Fantastic. Thanks. All right. The next one we have on here is App Registry. Do we have anybody to talk about App Registry? All right. Then the next one is Draft. Do we have anybody on to talk about Draft?
I can talk about Draft. So yeah, we're moving along. We've gotten some user feedback lately, which is really awesome. So we're working around some details with Draft Pack, changing some of those things, very minor changes. There's a homebrew formula out there now, so the install experience is a little bit easier. The latest release was 0.8, I believe. If you have any feedback or want to check it out, feel free to jump in the issue queue or the Slack channels. Thanks.
Fantastic. Thank you, Michelle. And then we have a project on here called CoopTest. It says what? Configuration linting research. Is that it? Do we have somebody on who can talk to us about that?
Yeah, that was me. I just added. So I'm basically talking at KubeCon about a whole bunch of sort of testing workflow tools. I'm doing a lot of research at the moment, and Michelle happily retweeted this and got me a few more people. For anyone who has done is doing sort of linting or sort of testing of Kubernetes configs, what I've sort of found is that there's loads of people. Everyone's got this sort of hacky script that makes a bunch of assertions. So we're not using these resources, or all of our resources have these annotations or these labels, or the naming convention is always like this, or images never use the latest tag. Some of that is generic, i.e. it's sort of best practice that everyone might agree on. Some of it is very organizational specific, like we use this tag schema. I'm trying to collect as many examples, because what I'm interested in doing and what I'll probably hopefully have shipped next week, in at least a sort of basic form, is a tool where a tool that does that, where we can all then just sort of share the tests without worrying about the implementation, without worrying about the language they're all written in and a lot of other bits. So yeah, if anyone is doing any sort of linting of configs, I'd love to know. So Gareth at morethan7.net or Gareth R on Twitter or Slack. But yeah, the idea is basically that with kubeval, which is a tool that does validation against the schema, that validates against the schema but doesn't tell you the sort of your organization's usage. CoopTest will be a tool that allows you to write assertions against all your configs.
So you see it as something that's complementary to something like kubeval, right?
Yeah. Yeah. Okay. So the thinking here is that if you're programming, whether that's actually you're just describing the data or you're generating that data with a high level tool, you want to know whether it's valid, but you also want to know that it's correct according to what you're trying to do with it. And in programming languages, you would tend to have some sort of syntactic validator, possibly a linter that sort of is community good practice, and also then unit tests, which are specific to your use case. And I'm sort of, kubeval addresses the first of those. CoopTest, the intention is to address the other two, in that we can share a set of tests that the community can come to some agreement on. But yeah, I'm doing as much research and finding as many bits of prior art as I can do.
Okay, do you just want people to reach out to you directly with their research, or is there a different path?
So yeah, if they could reach out to me directly, I think I promised Michelle I'll come back with that research to SIG Apps at some point and grab a 10-minute slot, because I'm going to write that up in some public blog post and get all of the code shipped as well.
Yeah, fantastic. And for the community charts, I'm happy to talk to you about that, because that's something we're working with.
Yeah, so I might draw you a line separately and chat about that testing bit for the charts, because I'd love to see that. I might have built some of the things that will make that easier. Fingers crossed.
Yeah. All right. Thank you. Anybody else with any other projects? 1, 2, going 3 times. All right. Then the last item we have on here is a discussion of 1.5. So behind the scenes and some mailing lists and other places, we've been talking about the discoverability of things in the ecosystem. And well, there's a lot going on when you think about it. So for example, we'll get into linting. I was looking for linting projects the other day, and I came up with a handful. And then I got into a conversation with somebody who told me about another one. And it turns out that, at least in my experience and the experience that I've had, is that it's difficult to find all of the things that are happening in a space, whether you want to consume them or collaborate on them or that kind of thing. The first thing, I've got a question. Is that a valid assumption? I mean, I've been working to it, and a number of people I've talked to have said that. I'm curious if this group thinks that this is a valid assumption.
You want to make that valid assumption explicit?
So the assumption is that finding projects in the Kubernetes ecosystem is difficult to know just what's out there, and what it does.
Yes.
Yeah. So as a bit of a data point, I did a birds of a feather last time at KubeCon in Europe on basically high-level tools for managing Kubernetes config, and I did a bunch of looking around and found a load, and people came up to me and said, "Oh, that's great. Can you add mine that you didn't find?" And the conversation was also people mentioned several. And yeah, there's at the moment the only way of discovering any of it is ad hoc.
Okay, so one of the ideas, and in fact I've started to craft a proposal with some others here, is to say, could we create something that collected those and made it easy to search and browse things by category and things like that? What do you all think of something like that? You can think of it as like an Amazon marketplace, except everything's not just an installable, right? You could think of it like, if you're familiar with Drupal or WordPress, the plugins listing, although they don't have to be hosted by that. They can be hosted anywhere. It's just kind of an indirection pointer. Almost like if folks are familiar with PHP and Packagist isn't like NPM or the others. It really is just a metadata repository that points you in the right direction to things. What do you all think of something like that to help make it searchable and easy to discover and find?
This is Scott speaking. Personally, I think it's a great idea to have something centralized like that for the community. This relates to exactly how you do it. I don't know, but this really relates to the last conversation we had about App Registry, right? Or are you thinking?
I'm not thinking about apps. This isn't like App Registry or Helm charts, because something like kubeval, that doesn't necessarily belong in a chart. It might be just a local thing you use, a local application, or draft. And so a directory of lots of things, not just installable, runnable applications.
Maybe not App Registry, but some sort, perhaps App Registry becomes a subset of a larger registry concept. We have a few registry concepts in Kubernetes already, right?
We do, because you got things like kubeapps.com built on Monocular and things like that. At this point, I'm getting less into the runnable tools and more of the developer tools.
Yeah.
But I can see how there might be overlap between these areas. Yeah.
Is the primary goal to make them discoverable to humans and provide the kind of educational resources we need in order to, say, read the documentation, understand what the project is? Or is it to create an abstraction layer where tooling can interact with it?
Because in my experience anyway, and others, please, by the way, I'm talking about my personal view here. If you have a different view or a different slant on this, please speak up. I want to hear it. And I love to have my views on this stuff challenged. But in my view and experience is that there's a human discoverability problem here. Right? And so it would be to solve that human discoverability problem of getting tools, not so much the machine. Now, we may eventually get into that, but if you've got 3 validators and you're going to try to look, okay, give me the validators. Okay, now I've got to try to decide between those. That's a very human problem based on taste and features and things like that. And so how would you provide a place where people could search and find the validators and then maybe have enough information to say, okay, these are the ones I'm going to learn more about, and then follow through to those locations and make their decision. So that way they don't say, I don't know what the options are. I'm going to go write my own again.
Yeah, so that feels like I couldn't find anything that did what I was looking for, so I built something, then I found something later, and that can be disheartening on both sides of like the person who created the first one and the person who created the second one, and obviously it happens more than once.
Yeah.
So I know obviously it's limited to GitHub, but GitHub topics, and as a lo-fi way of starting something off here and basically bootstrapping that data set, if we came up with a schema for like actual like GitHub topics, i.e. you add like there's two names, there's type tags, like that would immediately give us like some tools. And again, it's opt-in from the point of view of the creators, which I think is the right way around. But also then that gives us a set of things that keep growing without having to be curated. And ultimately, we might want a better user interface. We might want things that are not on GitHub. But as a super lo-fi way of finding out if this is useful, even if we were to say, get all of the things that we know tagged in some sort of like structure there, that would give us an idea of how many there are, and whether that view is useful in a really lo-fi way. Like no one's built anything at that point. It has limitations, but that might be an interesting starting point.
I do like how you've jumped from it's not just a valid assumption, but here's how we go build it. To just back up for a moment. Well, I like where you're going. Does anybody have any other opinions on just whether this would be useful or not? They're happy with something because like there's an awesome list out there today, and is that acceptable? Sorry, Raphael.
Yeah. So, well, what you're talking about, I first of all, I do think it's a real problem, and it kind of reminded me of an interaction I saw the other day on Kubernetes Slack, and I'm in the Kubernetes users channel usually, and stuff goes by too fast for me to follow it that closely. But I noticed somebody was jumping on and asking about how to deploy their application, and they got a range of different answers, but some of them were really about or some of them were pointing at COPS, and they said something like, "I'm looking for a simple like one-line tool to deploy my app," and COPS, and that, well, to me, it pointed to a little bit sort of a human community, or of almost like a user community problem, right? Because there's sort of a lot of different potential roles when it comes to interacting with Kubernetes. There are people that tend to sort of more operate it, and then there's people that are just trying to build applications on it. And so, and there was definitely crosstalk going on there, and sort of miscommunication because of that. And then I know there's a whole lot of other channels on there that are sort of more narrowly focused on different topics. But yeah, I do feel like there's a real problem when it comes to sort of funneling people who are new to Kubernetes, and they know what they want to accomplish, and there's a whole set there's a whole tooling ecosystem out there and a set of choices to do it, and I feel like they almost need to talk to the right set of people first to figure out how sort of just how to look at the landscape. So I don't know. I mean, but it definitely seems like a real problem.
And I think to piggyback on what Raphael is saying, and come back to something that Matt Farina mentioned earlier, I did Drupal development for a while as well, and the experience of findability from Drupal.org is vastly, vastly superior. From I was counting. If any of you read my blog post about this, because I vented about it a couple weekends ago, in 3 clicks I could find out all the implementations of whatever I was looking for, all the different to-do lists, modules, all the different database back, all kinds of things. It was very easy. I'd go to Drupal.org, I click on the search thing, I type in something, and I click again, and I'm off there. And this was ecosystem wide, and people would self-register. So you develop something, and you feel like it's ready for the world. You go, you put it there, and people can find it immediately. And the documentation is all centralized and is all in the same theme, so it's fairly easy to navigate. And that experience, man, I miss that, because in the Kubernetes world, even before I can do anything like start a new project or work on anything, it's like a little bit of Googling, a little bit of navigating GitHub, a little bit of asking around. And even at the end of that, I rarely feel like I have a full vision of all the work different people have done in related areas. And several times I've started projects only to find out several thousand lines of code in that there was already something out there that was very similar. And nothing's worse than wasting that kind of time only to discover that then you end up looking like a jerk because you're re-implementing something somebody else did too. So anything that could increase findability, allow people to self-register. I like Gareth's idea that, tags are an easy, simple way to opt into something, but opting in is the point that I think is salient there, right? So yeah, self-registration, ease of or standardization of how to get to documentation. So there would be a link or something like that. And, that kind of stuff I think alone would go a vast distance in helping, especially people who are new to Kubernetes, find what's out there, what's available, reduce duplication of work, increase the general level of our very, very large user community.
Yeah, just I think that's I think those are some great thoughts. Just something you said made me think of the term expert blind spot. I feel like, right, Kubernetes is Kubernetes is a really powerful tool, but it has a huge learning curve. And so there's a big expert blind spot that sort of the community needs to cope with. And so I feel like it might help to maybe almost think of it as a two-step process, right? One, find the other people that are trying to do the same thing I'm doing. And two, look at the tools that they're using to accomplish it. Because that way you'll get sort of the new users who are sort of at the same level, kind of collaborating to document how to learn what it is that they learned at the sort of their stage of the journey, and they won't suffer from the expert blind spot. And so you'll get sort of the right documentation for that point in the learning curve.
All right, folks. Well, thank you for the lively discussion. We are at the top of the hour, which means our meeting has come to an end. If anybody is interested in maybe working on a problem like this at some point, if this is something we move forward on, I'll definitely be looking for other folks. Thank you for the input, and thank you for a lively, full meeting today. Everyone, have a wonderful 2 weeks. Remember, we are off next Monday for the U.S. Thanksgiving holiday. See you all in 2 weeks or online. Have a wonderful day.